My friends, in my previous video, I explained low pass RC filters. Now we look at high pass RC filters. Filters that allow high frequencies to pass and block low frequencies. So, okay, they disallow the passage of low frequencies. Now let's see how this happens. Now, if you have these two components are in series, okay? So what we are doing here, just to look at the way it is. Imagine it to be this way. You have your capacitor, you have resistor, okay? This is C and R. Now you're using your voltmeter to measure the voltage across this resistor. That's VR. That's exactly what we're doing. So they're in series, okay? So if they're in series, the current passing through this here, it's called the one that passes through. Of course, it has to pass through this IC. It's more conventional to write the current with the current after the component. But let's allow it this way. So the current that passes through this R is IR. So the equal being in series. Okay. Now current flows from area of high voltage to area of low voltage. So there will be a potential difference. This voltage produced by the voltage source will drop across this capacitor. The rest will drop across the resistor which we're measuring now. So the voltage here and the voltage here, the difference will be Vs minus Vr divided by the capacitive reactance of this capacitor, of course, which is the resistance offered by the capacitor, because the voltage between these two, because this has to be at a higher potential difference with respect to 0. This is 0 at. Okay, so we have VR minus 0 divided by R. So we have Vs minus VR over XC equals VR over R. So we have Vs R minus VR R equals VR XC. So VSR becomes XRXC. So VRXC, sorry, plus VRR. So that gives us VSR equals VR into XC plus R. So VR, which is the output voltage, will now be the voltage source multiplied by the resistance of the resistor divided by the capacitive reactance and the resistor. Okay, now we know that the impedance Z is XC squared plus R squared. Okay, this we know. Okay, now if you look at this, so we know that in physics F, capacitive reactance is 1 over 2 pi Fc. Now if frequency is high, Xc is 0. See that? X is 0. If X is 0, it means that VR equals VSR over R. So you have Vs. So if F is large, capacitive reactance is 0. So VR equals, or V output becomes equal to Vs. So there is passage of signal. But if F is so small, Xc is too big. Okay, it's too large. So if it's too large, Vs of R, infinity plus R is infinity. So you have infinity, which is 0. Okay, so if it is large, becoming large means frequency being small. If frequency is small, the output voltage is zero, and so it doesn't allow low frequency signals to pass. This is the reason it's called high pass filters. It only allows high frequencies to pass. Thank you very much.